board. Fibro meeting, 6th of November 2020, part 2. All right, so we left off here. So this is, yes, just captures. And this is the same thing, but just for fibro prevalence.
Okay, so you need to share your screen. I don't know if you share.
Oh, you're not. Oh, sorry.
I can't see anything.
Sorry. No, I'm already confused. Okay, and welcome back, Charles. Right. So as I said, this is caught by season, and error bars are by months. Which I think is a fun graph. Like I'm not. Trying to see if, like, yeah, so Matalai generally has less captures, I guess, but not necessarily. High variability.
So maybe.
Just trying to see what if I'm seeing anything in this graph.
Are you able to get a mean capture rate per season overall?
Sure.
Or mean number of turtles caught, rather, not capture rate.
Sure, per season. Let's do that. So goodbye. Ocean season. Caught, right? That's it.
Okay, we can use that. So we can say that the highest capture rates, or the Kaskazi was the season in which most turtles were caught. So we can put this into the seasonal part of the results.
Yes, but this is not adjusted. Oh no, it is. No. Yes. No, this is fine. Never mind. I wanted to say this is not adjusted per month, but that's not true because it is, because the caught is in a monthly. Yeah. Okay. Cool.
Wonderful. Okay.
Yeah. And the deviation, and maybe we can also do this. This is just to see the whole distribution.
Okay.
And that's just the mean. And label. Wait, how do I do the labels here? I'll figure out the labels later. But yeah, so maybe this even, right? Just gives more information than just the mean. Also, it's interesting that they're not normal at all. Right?
No.
This forget all the fancy terms, but it has like yeah, like a big tail on the right.
I'm thinking for the overall, for the seasons, we can make a box plot, which will show everything like the outliers and the interquartile, the mean and median, the median, and so on. And we can talk about the mean and so on.
So you mean box plots?
Is there a Hebrew version of this, Ita? Can you code in Hebrew?
I actually never tried because it's a mess because Hebrew goes right to left.
Ah,
So it makes things weird.
okay.
A lot
Just I
of
was
things. But I think yeah,
just
you know what?
curious.
Let's see. Uh, huh. Yes, I guess yes.
Okay, cool.
Looks like yes.
Sorry, I don't know why I thought about that just now. Anyway.
All right. So yeah, so x would be our x-axis. The season, right? The ocean
Uh-huh.
season.
Box plots. Um, yeah.
X the ocean season, and y would be the cot, right?
Mm. Yeah, that's not bad at all. It even has a, okay. And we can adjust that. So looking at that, I mean, yeah, there's a few more turtles caught in Kaskazi season, but actually there isn't that much difference between the seasons. You see, that's showing it a bit more clearly
Mm-hmm.
because the difference between the interquartile ranges, they're all the same. They're all between 40 and,
Mm-hmm.
well, yeah, 40 onwards going up.
Just maybe like a fancier. This is the violin plot, so it's basically a box plot, but oops. So it's basically a box plot, but also with he does this kernel density estimation nonsense. So you get
Hmm.
like these fancy curves.
Yeah, it's pretty, but I don't think it's what we need right now.
Yeah, yeah, it's
It's
also misleading, but it's just I don't know, just interesting to
yeah,
see, just to see this a bit more, that this has more of a
yeah, it's
because
more
Kazi has
elongated.
yeah,
It
but
has more of a range than the other seasons in
we
terms
can
of,
see it. We can see it in this plot as well.
yeah. So we can just squash it a little bit to make the boxes taller, if you know what I mean. But that
Right.
but already that is something that we can we can put in the results just to say, and I think it will be backed up by the ANOVA because I think we did an ANOVA between seasons and we didn't get a significant result, right? I think we did that. I may be wrong.
Yeah,
Yeah, we didn't.
we shouldn't. Not sure what we did, but looks like we shouldn't get.
Yeah.
Not sure what we got, but yeah. Okay, so here you want to just change the proportions, right?
Just change the proportions to make it taller so they're not so squashed.
Yes, to unsquish the boxes.
And thus you can actually just send them or put it into the paper, or you put it into the paper, whichever,
Mm-hmm.
and we can use it already.
Yeah.
So I can, yeah, I can, or there's somewhere that you had done an ANOVA or something at seasons and it was not significant, and that's something we need to report as well.
Yeah.
So it means that it's not related to season. Okay.
Yeah, it should be here. Although I think the ANOVA came out. Let's see. Seasonality. Seasonality of captures. So yes. You're saying no wait, this is normality. It measures ANOVA. Low p-value. But no, they are different somehow.
Really?
That's weird. Wait, but the F right? You're the
That's a
expert on
high
the
F.
ANOVA. This is repeated ANOVA by year.
Oh,
So yeah, which is actually more accurate than this is. So we're seeing basically this graph in that ANOVA.
okay. Okay. But
And
overall,
here it's saying that the blue, or let's say the, I guess, yeah, it looks like the blue comes from a different distribution, right? If we look at it this way, and the orange. Yeah. I mean, it's definitely more correct to do this in a repeated ANOVA because the variance, most of the variance is explained by the year, right?
this graph, uh,
Yeah, but it's just not as clear. But that's why I guess we do the statistical tests, right?
yeah. Because overall, if there was like a clear difference between seasons, it should come out regardless of the year. You know?
Unless the year has the most variance, like if there's years that they have like a big like difference, you know, because we want to account, like we have to normalize for the differences in the years.
Yeah. But if we look at it here, the year itself, okay, there are differences in the years, but they're not big enough to produce a difference in the seasons. Because if you look at the seasons within the years, the pattern is pretty consistent, especially from 2006 to I think 2013 or even more. Kaskazi always has the highest catch
Yeah.
in those seasons, in those years.
Yeah.
And then followed by Matalai the lowest, and then so on. So the pattern within the year remains pretty consistent. So you may have that variation internally due to the years, but then overall, it doesn't amount to much, as in the difference between the seasons is not that big overall.
Yeah, I mean, depends like how much is big, but definitely Kaskazi is consistently
Yes.
bigger than Matalai, right?
Yeah, but not big enough. Because if we ran an ANOVA on the graph we just did, already looking at it, you can see there's not that much overall, like in this time period altogether. If you look within the box plots, this is what we're looking at now. There's definitely internal variation, which is being shown by the, let's say, the whiskers in that box plot with little caps and what have you. There's variation within the years, and that's fine. But variation between the years is not big enough to be significant. I mean, between the seasons is not significant. Like that variation, let's say, you see that variation in 2012 is and 2013 is probably the biggest one you get.
Yeah, and
In
you're
the
saying
rest,
that's not a lot.
that's not a lot. In the grand scheme of the 19 years, it's not enough to show like seasons have a significant difference between them.
Okay, this is not significant enough.
No. So
Right.
in ANOVA terms, this is the internal variation that we're seeing here. But then when we look at the overall, like, is season really a factor? It's not. The catch rates are fairly consistent year after year after year. They're not significantly varied. But
Right.
we should do it just to see on that new graph that we did just the
This
other
one?
moment. Yes.
Just to do a ANOVA on the, like a regular ANOVA on the
Yes.
seasons.
Yes. Just to confirm. I think you might have.
Not a repeated ANOVA. This syntax. So the data is this. Subject is this. Caught. And no, then connection is relevant. This is just no. Okay, I'll do this later. I need to check the syntax of this.
Okay.
Another on, and it might be later here somewhere. So just regular Nova on ocean season. Yep. Cool. Okay. Cool. And this is too much detail, you're saying, right?
That's not so clear.
Yeah.
It's not, I mean, it's showing an interesting pattern and trend, but it's a little beyond what we want to do. Yeah, I think we want to just get the graphs and the results out, and then we can write a discussion, and then
yep, cool.
Maybe even by the middle of the month. Wow, you can have something. I'm not going to put timelines, but I'm very.
Sure.
This is yeah.
Okay, so this is the same type of graph as before, but here we're looking at prevalence.
Okay. There's definitely a difference.
Yeah.
What you mean in Matalai, right? Matalai being higher?
You know, I don't know if it's seasonal difference, but it's a yearly difference.
Oh yeah,
for sure.
For sure.
Yeah.
For sure.
Seasonal. Seasonal, we should check it out.
Yeah, so I did like the Friedman because I can't do repeated ANOVA on this because it's not normal. So I did the Friedman just on this here, and I got this p-value, which is close to something. We can maybe play around a bit with the data. So like, crop a few years out to get some more stuff if you want to insist on.
No, we just, I think we stick with the data set we have. Like that timeline is that timeline we have and just do
Okay.
like what we have there.
Cool. So this is the p-value we have for the Friedman test on on prevalence.
Do we have a seasonality on prevalence? Did we do that?
This is seasonality. Yeah, this is the seasonality on prevalence. Oh no, sorry. This is on the land seasons. We're getting this p-value. We're actually not getting a decent p-value for the ocean seasons.
Okay, which makes sense.
Yeah, and one thing, the thing that I wanted to do is to also check like lags in the seasons, but I think that's too much work.
It would be a bit much.
Yeah, I have to change to like a Bayesian and start. Yeah, it's a lot of like thinking and coding and working. It's.
Yeah, and I think something we can try to consider later on.
Yeah.
For in the discussion or something. Yeah.
Yeah, exactly. Give us money and we'll do it later.
Exactly. Yeah.
Okay.
Do you mind just drawing a box plot for the prevalence by season, just to see what it's looking like
Sure.
compared with the court?
Sure. So we did there, right?
Yes.
So this is my data. Cool. Um, why is this thing? So again, it's not a. It's a question of how to visualize this because the data is not normally distributed.
You see, for I wouldn't be too worried about it not being normally distributed, because disease data almost always has like a
Yeah.
binomial. Sorry,
Yeah,
not
no,
binomial. Yeah.
I mean, it makes sense, but it's just it's annoying to visualize.
Yeah.
Because visualization tools apparently are all about normal data. This becomes very clear when you're trying to. But maybe do the trick I did there with. The histograms on top of each other. Like, I like it because it just shows a lot of stuff. And they look sort of similar, actually.
Yeah, they do. I don't see a big difference there either.
Yeah, or maybe.
You see, the spread is continuing for all seasons.
Yeah. Yeah, looks pretty similar, except that you have more more zeros in Kaskazi, right? Let's see it there. More zeros. Yes.
Oh, in Kusi and Matalai, especially those early years. Well, 2003 and 2004. But there was nothing caught in 2004, so that's deceptive. But yeah, it's really varied.
Yeah.
You see, 2008 there was hardly anything in Kaskazi, and then yeah, in several years, Matalai seems to be coming out. Could we do a mean profile for like Matalai, Kaskazi, Kusi infections? Mean prevalence?
Mean prevalence, sure. Oh, look at that. It's right here.
Oh. Okay. Yeah, so Matalai has highest mean prevalence.
Yeah.
But then again, they're not that different at all.
Yeah.
Okay. Okay.
Cool. So you want something with this, or
I'm trying to.
maybe another way to visualize it?
Another way to visualize it would be good, because we're finding, the season is not significant. So I'm trying to
show that it's not significant somehow.
Yeah. What about just
Maybe the box plot then, although the box plot looks weird.
It's not very nice, no.
You can do just a table with the means, or maybe this, or like maybe this but nicer. Like let's There's a KDE here I can do. No. What? Yes.
Oh,
What's that? The zero. Oh, but you see, it's lying because
yeah.
it's doing the above zero stuff. So maybe.
But we could do like a line graph. Sorry, not a line graph, a bar graph like you did above. So because it's season and it's not significant, we can do a bar graph that combines the cohort and the prevalence with the prevalence on top, and then a trend line going through for both.
What again? Sorry.
So we could do a bar graph, you know, like the ones you did, but then you combine them into one. So like you would do like you know, the one that you did for overall prevalence over years.
Overall preference.
So
this.
Yes, like that one,
Okay.
that one, yeah. So we would do something like that for season. So these bar graphs would be divided into seasons, and then we have a trend line for the number caught and also for fibro infected.
So it's like this, but with a trend line, like here and here.
For both,
right?
yeah. And then this it would be showing seasons. So actually, maybe a trend line for the seasons. Sorry, because it's a season graph.
A trend line for the seasons. What do you mean?
So we do a bar graph for the seasons. Within each season, within each bar for each season per year, you'd show the number caught versus the
so you're
number
saying something like
infected.
this, right?
Something like that, but combined with caught. So this is showing caught only.
Yes.
But then the bar graph on top, we'd add like the number infected.
Yes. So to add
And
infected into this.
Exactly. Plus the error bars.
The caps, you mean?
The caps, yes. What did you call them?
I don't know. I don't really have a real name for them.
Little cap
little
things,
tip,
little
little
tippy
tip
things. Yeah. Then we can add those, and then
so add infected or maybe prevalence, right? Would make
yes,
would be like on a different axis, right? There would be like a different axis here of prevalence and maybe like a thread line.
Not really. You won't need a different axis. The bar would show
prevalence.
But the bar itself would show the proportion that are affected. So this would change from
okay, so not prevalence but infected.
Yes, number infected, number caught. So it's looking like what you have above, but then in your y-axis you have percentages instead of total numbers or absolute numbers.
What? So to change this axis into
percentage,
but then what is this then?
This is absolute numbers. This is total.
Okay,
caught.
so yeah, so yes, doing two y-axis.
No, you don't need to. So
wait, this is total number caught, but you also want to do prevalence.
I want to show.
No.
So you see in these bars that you have here for the total number caught, right? There should be a section. Each bar should be divided into two sections where you're showing infected and uninfected turtles, all within that bar of the total number
like
caught.
This.
Like that, yeah.
Cool.
And the error bars. But you see now on the y-axis, it would come out as percentage. So someone can look at the bar and see the percentage infected compared to the percentage not infected.
So each of the, but then
you
it's
just need one.
Yeah, but then you just do
What was a...
1 second. So, let me see if I get what you're saying. Captures. Done. Uh-oh. Cut. Then, I mean, so if I understand you correctly, you just want this. What? No, wait.
by season?
Right, something like this.
But a bar chart of season.
Yeah. But basic. But I'm just not seeing how is this like a bar chart, right? Because why are the bars?
I wish I could draw somewhere. I wish like these are the limitations of online.
Yeah.
It has so many limitations. This is just another one.
Yeah. I think we're all sick of the. Okay, so this is a bar chart of the prevalence.
Yeah, that's the prevalence. Now, so imagine that put on top of the total cohort, but then you have like you've done on the graph above, you have the prevalence proportion showing within the bar, just like that. And then
But if it's a
maybe
proportion, you see what I'm saying? So it's just one number, so you don't need like two.
exactly, you don't need two axes. You just
You don't need two bars. It's just one bar. It's just this.
no, but you want to show the percentage of turtles caught in that particular season that had prevalence. I mean, that had fibro or not. You know what I mean?
This is the percentage of turtles caught with fiber or not.
I was hoping to show it compared to the population, like the number caught per season.
Yeah, so I'm thinking.
But
what I'm thinking. See if this works. Doesn't work. Something like this. What? Oh. Like this. No. Didn't work. Anyway, so I'm thinking like this. Fuck. Like this. No, not by year though. So basically to superimpose this on this, right? So to have this is the prevalence, right? And also put it like here on this as well. So you actually have like the number, like the actual numbers on the y-axis. And you also have this, which is like a clearer representation of the prevalence, right? Because it's not easy to know, I don't know, like here or here where we're more caught, but here it's easy. You can see the same prevalence. And then you have like here like numbers, like actual numbers, and here you'd have like prevalence from 0 to 0.2. And this would go. That's what I'm thinking.
Okay, what I recommend, you try and produce something like that, and then I'll also give it a go on my side,
Mhm.
and then let's see, maybe if we can do one or the other, or decide on something in between.
Okay, so but the idea basically is to show the seasons, the years, the captures, and the prevalence in one graph, right?
In one graph, yeah, because it's insignificant, so we can't afford to put too much
Yep.
information about it. So we just say it wasn't significant, but this graph shows the variation in the trends between years, in the capture and prevalence trends between years.
Yeah. And the seasons. So seasons,
Yes.
captures, fibro, and prevalence all in one graph. Like we can for sure, like if we skip the actual numbers of the prevalence, I think never mind. We'll
Yeah, those last two would be the same anyway. But yeah,
Yeah.
it can happen, I'm sure.
Yeah, okay, we'll play with that later. And we don't have much time. I don't want to go.
That's okay, but we've covered quite a bit already.
Yeah.
I'm trying to think. Yeah.
I just want to see by location. I did a bit. So.
Oh, nice.
So this is by location. Just looking at yearly location. So I didn't look at monthly location because in prevalence, because then it gets like weird because the numbers are not high enough numbers. So this is yearly. But yeah, there's
okay.
Let's say like the mouth of the creek, for instance, really became a thing after 2012.
Yeah, I also found that significant with my
So the south and the north, like used to be a thing and no longer. So I think that's probably the most interesting thing.
These two are this was significant in my thingy. Can I? I know I'd ask so many times, but would you mind drawing a box plot of this? Maybe when we enter for our third meeting, although the third meeting won't be so long.
Yes. Yes, a box plot of a location, because this is prevalence. So just by location and okay. So forget the years, right?
Yeah. Like overall.
Yeah.
And I think it will come out very clear because it was significant in my analysis. So I'm expecting it should come nice and clear differences according to location.
Yep, this is it. I think I don't know. I think the years here add like a lot. Yeah, because there's really trends. You can see like the north going down and the north and the south going up.
Is there? I wonder if there's a better way to visualize it than
heat map in a video in a heat map.
Yes, we were going to do the heat map. Yes. Okay. Sorry, I forgot about the heat map. Okay.
Yeah, the heat map, but like heat map over time, maybe with colors or something. I don't know.
That's complex for a paper. It's like you were talking about the time analysis. It's not. Let's finish the basics and then see.
Yeah. So maybe like this plus a heat map, I think, makes it pretty.
I'm not a fan of this bar graph. I don't know why. I know the trends are showing in the years, but I don't know if it's. I think the heat map for location might be better.
Mhm.
Yeah.
All right. I don't see any other way of seeing, like, showing these trends.
Yeah, we don't need to draw a graph for the location. We'll just do a map and leave it. But then we can describe the trends.
Maybe